Hey class. First, before we get into the assignment, I just wanted to go over one last thing when it came to importing Revit geometry into Rhino directly using Grasshopper. So there's one other way, so you can isolate the actual element type. So at the end of the lecture for attendance, we were filtering the specific elements and then using we're using the name of the category, so walls, floors, roofs, those very generic names to create the names for the Rhino layers. And if you wanted to be even more specific, especially if you have a lot of different element types within your Revit model, let's say you have 3 different types of floors, you have 4 different types of walls, 2 roof systems, what you can do is select the element type by name and plug it in from whichever document elements you are using. So this one is for the walls. You can plug it in from the floors, etc. And it will bring up all the different types of walls in that specific group of elements. Of course, we only have one type of wall in this file, so it only brings up the 12-inch masonry. Then you plug it into the element type identity, which essentially just looks at the different type and breaks it down by category and name. And then you can plug that name element output, into the layer input. And then when you actually bake it and put it into Rhino, give it a second to warm up. Now, instead of just having wall as your layer name, you have generic 12-inch masonry. And you can do that for each specific type of wall or each specific element type, so that you can organize your Rhino file even more than you were. So that was just something I wanted to cover really quick before we got into the assignment. So the assignment is going to be creating this bad boy. Let me open it up real quick. So we're actually going to be creating an image sampler in Revit using an actual Revit curtain wall, using a custom curtain panel. So that's just left over from the old script. Let me close out and start completely fresh. I found that if I'm ever going to work on a new Grasshopper script through Rhino.Inside, it's good to close everything out, reopen it all, just to get a nice, clean, fresh start with the Grasshopper or with Rhino.Inside. So the first thing that we're going to do is we're going to create a custom curtain panel. So we've created a couple of those before with custom profiles, and we've also created adaptive components before that work similarly. This one is going to be pretty straightforward, but we're going to be implementing some formulas into the parameters tab to be able to make it so that when we plug it into the Grasshopper script, it becomes parametric and it talks back and forth between the script and the component, the Revit element. So under families, we're going to go new, and then curtain wall panel. Remember, we sent out, I think we sent out a link. If not, you can find, if you are missing these families, it means that this guy is not linked to the correct folder in your computer. And if you Google Revit family file location, it will come up with the file location of these families, and you can follow that to get to them. Because if you've installed Revit on your computer, there's about a 99% chance that those families are downloaded with it. There are some cases where they don't, and you can download those specific families separately off the internet. if you so choose, or if you can't find those families. So anyway, so we've opened up our template file, our panel file, and I've gone to the exterior elevation. And so what this brings up is 5 different reference lines, a center line, and then 4 perimeter reference lines. What we want to do is create an extrusion that utilizes the 4 boundary reference lines. And what I'm going to do is use the rectangle tool. I'm going to snap to the 2 lines. And then when you have a drawn line on top of a reference line or a reference plane, these little padlocks come up. And if you click all 4 of them, that means that all 4 of these lines, even though we are in the drawing environment, those still will lock to those reference lines. And then what we're going to do is and then we'll offset. And this doesn't need to be specific. What we're going to create is a panel that has a void in the middle, and that void is going to grow or shrink depending on the gradient of the image that we use, or potentially a point attractor in another case, etc. So it's basically going to be parametric to whatever influence we so choose. So to do that, we got to set up some parameters, dimensional parameters. So the first one we want to do is width, and then height. So width, let's set up over here. Just type in width. And then this is going to be an instance parameter, and it's also going to be a reporting parameter. So this is not this dimension is going to change depending on the our curtain wall system, and it's going to fluctuate. This is not really going to be specified by us. This is what we call a reporting parameter, and it's going to be used in an equation that we set up for the offset panel. So you'll see in a moment. So width, and then do the same thing for height. Whoops. Height. Same thing, instance and reporting. Okay, and then we're gonna do couple offsets dimensions. Alright, so these 2 are going to be the same. So we're going to set those up. And we can do offset width, or W. Also instance. And then these will be offset height, or offset H. These will also be instance parameters. Okay. Alright, and then let's go in to our family types up at the top. So with the reporting parameters, they come up with these reports right here, and they are set, so they are not allowed to be edited. It's only the other instance parameters that can be manipulated. So what we want to do before we start typing in any formulas into the offset H or offset Y's, we want to create 2 new parameters. So one will be a factor. Oops, that was edit, sorry. Go to new parameter. And so the first one is going to be an offset factor. So the offset factor is basically a number from 0 to 1. It's kind of like the NRP, I believe, in the adaptive components that we used. So it's a value from 0 to 1, and this is what is going to be created in Grasshopper to create those gradients. So it's going to use values between 0 and 1 to tell this panel exactly how much to open or close depending on that factor. And so it needs to be an instance. And then also, this is not going to be a length. It's just going to be a number between 0 and 1. So we change it from length, type of parameter length, to number. Press OK. And then what we also want to do is create an offset. Oops, did it again. Create an offset override. So this is a little bit different. This is where the formulas are really going to come into play. So like the offset factor, we want to change this to number, make it an instance, press OK. And so the offset override, we don't want this value to ever be 0 or to ever be 1. Because if it's 0, then it cancels out and you're going to get an error. Same thing with 1. Because one way is going to go to the boundaries of the panel, and you're not going to have a panel. It's going to be an empty panel. Or it's going to go all the way to the center and create a fully solid panel. And because of the way that the panel is set up, it's just going to error out and go to a default panel system. So we want to put some boundaries on that. And the way to do that is to create an if statement. So if the override, or excuse me, sorry, offset and make sure that you spell it correctly. If offset factor is less than 0.05, then we want it to be 0.05. So comma 0.05. That's saying that if this offset factor is ever, let's say, 0.01, then this offset override is going to go to 0.05. And then another one for the max, if parentheses offset factor is greater than 0.95, set to 0.95. And I think, whoops, sorry, didn't mean to. Make sure that you put a 0 before the points, decimal points. And then this needs to end with comma offset factor so that it knows it's referencing the offset factor, and then hit here, parentheses expected after function name. Oh, that's weird. There we go. Sorry, I had a plus in there. So I'll drag this out so that y'all can see exactly the full statement. So if's offset factor is less than 0.05, make it 0.05, comma, if offset factor is greater than 0.95, set to 0.95, and then referencing offset factor parameter. So right now, this offset factor is at 0.0. So this override automatically goes to 0.05. Same thing if we did 0.99, it goes to 0.95. But if we did 0.93, it's going to be 0.93. Okay? Alright, so that's the formula. That's to make sure that we don't go all the way up to 1 or all the way down to 0. Of course, you can do really small numbers. So you could do, if offset factor is less than 0.00001, make it 0.0001. If 99999, etc. But I just chose 0.05 and 0.95 as a starting point. And then what we want to do here, so offset width and offset height, we want to reference both the width and the height, as well as the offset override. So what we'll do is do width divided by 2 times offset override. Now what this does, if we look at our panel, is our offset W is going to be half the width, and if our offset override value was 1, that would create a fully solid panel. So we do the offset width divided by 2, so it splits it up, multiplied by the override, which gives a percentage between basically the edge of the panel and the middle of the panel. And then we want to do the same thing with the height divided by 2 times offset override. If we press OK, there we go. Oh, that's why. I was wondering why that was going. I had width and height backwards. Make sure that you use height with your offset H and width with your offset W. There we go. Okay. Much better. All right. So now, one other thing that we can do really quick, set the thickness of the panel. We've done this before many times. So what I want to do, let's go in. Let's set up a new parameter. Let's call this thickness. Type parameter. Press OK. We'll make that 1 inch. So we want our panel to be 1 inch thick. Now, because we have our extrusion end start, and we want the panel to be centered on the curtain wall grid line, we'll create 2 panels. Thickness negative, which will be, damn it, I'm sorry, I edited it again instead of creating a new panel. Sorry. Thickness negative, and then one more, thickness half. You can name these anything. You can do them thickness 1 or 2. Basically, each one is going to be thickness divided by 2, and for the negative, this is going to be thickness divided by 2, and then put that in parentheses, times -1 to negate it. So now we have a negative half of the thickness and a positive half of the thickness, and what we can do with those is use them for our start and end points of the extrusion. Half and negative. So we go to 3D. Now we have a 1 inch panel that will be centered on the grid line. So let's save this panel as something you'll remember. Image, let's see, gradient panel. Alright, so now what we need to do is start a new project. So file, new project, open up our template, documents, alright, so what we need to do is create a curtain wall family type that has the gradient panel in it. Actually, what we need to do first, go back to our gradient panel and load into the project. Make sure that the family actually lives in the family. Alright, so then let's go down to a curtain wall. Edit type, duplicate this as gradient wall, and then under curtain panel, go down and select gradient panel, and then down at vertical and horizontal spacing, let's do fixed number. Remember, fixed number is going to be dependent on the individual wall itself. It is not a family type. It's not a type parameter. It's an instance parameter. So we set this up. Sorry, we set this up in the instance parameters tab at the right. So I'm going to make this as square as possible, the height and the width to be somewhat the same. And then I'm going to do a 10 by 10 grid. Okay, so that was up over on the right under vertical and horizontal grid. So now we have our base. Now we have our base file that we can start to manipulate or use as a base to manipulate in Rhino.Inside. So let's go to our add-ins page under Rhino WIP. Open up Grasshopper. Alright, so I'm going to be not really focusing on this environment. I'll check in every once in a while, but right now I'm just going to maximize the screen, and I'm going to get started. So we need to first pick the curtain wall or curtain panel system. So go to Model Categories Picker. It's going to bring up that model types. Do the drop down and go to ceiling or excuse me, curtain panels, and then go to element type by name. Oops. Element type by name. Plug this guy in, and then go drop down and select the gradient panel. Excuse me, sorry. And then we need to select an element type filter. So this filters the specific type, and then a document elements to then populate all of those different types, all the different all of those specific curtain wall panels in the document itself. So if we look, it still doesn't have a preview. So after that, oh, sorry, that's why you can't preview it. Because the next step is to do an element preview. There we go. Plug that in. And then what we want to do, it creates a mesh from each one of these panels, and you can start to see the preview underneath it. The preview allows you to preview the geometry without actually creating the solid geometry. So it keeps your computer speed down. It also creates meshes from it, which you can then use to do a mesh area, or just area, and plug that mesh into the geometry. Now remember, with the area component, not only do you get the actual area of whatever surface or geometry that you plug into it, but you also get the centroid of that geometry, and that's really crucial when we're creating these gradient patterns, these parametric patterns. So next, what we want to do is create a patch. So what we're going to do is create a surface from these centroid points, which we can do by plugging into there. One thing to remember, we can't create a patch from just one point. If we look at a panel Remember that all of these points are coming in as separate individual panels. We need to flatten that list so that the patch uses all 121 points to create that solid surface. And then what we're going to do is use surface closest point. Use those centroid points as the point input, and then use that patch as the surface. What this does is it basically reorients all of these points onto this surface, and then if we go in and we reparametricize the output of this surface, what that does is it reorients this surface's U and V from 0 to 1. So if we look at this output of the UV points, which we're going to use as our basis for that offset factor, they're all from 0 to 1. None of them go any further. And that's really helpful when we're creating that factor, because remember, that factor needs to be between 0 and 1. If we use just regular points, it's going to all depend on where those points are in space. But this UV point that we've created from this patch creates those individual numbers between 0 and 1. So using those numbers, what we're going to do is deconstruct a point. So we're going to deconstruct these UV points into their X and Y components. And then we're going to remap those numbers, make sure that they're between 0 and 1. Or, excuse me, it's going to clean it up a little bit. And then we're going to use those remap numbers for the offset factors. So what we need to do is use bounds. So bounds is going to provide us with the lowest and highest number in these X and Y lists. And then we're going to remap those numbers make sure that we plug our X into our value and then our bounds into our source. So our domain out of here is 0.04 and 0.95. We want those to be between 0 and 1, so we get a true, clean, full spectrum of the list. Because if we actually, here, I'll show you real quick. So what that patch does is it goes outside the bounds of our curtain wall. And so it's offset like 2 feet on this side, 1 foot on this side. And so our 0 and 1 are a little bit skewed. That's why it's starting at 0.04 and ending at like a 0.95. So what the remapping is doing is instead of saying this bottom corner is 0 and this is 1, saying that that bottom point, which we're using for our parametric, or what are we calling it? Offset factor. Starting at 0, and this point up at the top right is our 1. And so we disregard the overhangs of the patch. So plug that domain back in here. So now we have fully remapped X and Y. We're going to rebuild our points, construct point out of our X, Y, Z. Plug our X into the X, Y into Y. And then now using these points, what we can do is use these points as a basis for our image sampler. So on Canvas under Files, there'll be a gradient file that'll match this one. If we double click in and go to the file path and wherever you guys download it, so mine is. It's going to look like this. So it's going to be darker in the top right hand corner and lighter in the bottom left. Open that guy up. And then remember to adjust the color brightness. Plug this guy in. So now it has the same amount of points dividing this image up as there are curtain panels. And then what we're going to do is what we're going to do is so we could plug it's going to freeze on me. Oh, there we go. What we're going to do first, so we could just plug this into the offset factor into the parameters, and it could be good, but we may need to invert the values. So let's say that in the dark patch we want it to be open, but when we plug it in there it's a close. We can use the following steps to toggle through it. So what we want to do is use a value list. So value list, if we right click, go to edit, so it's going to say basically in all of these it gives you a drop down list that you can edit, obviously, and then depending on that drop down list it gives you a certain value. So for us, if we want to keep it normal, and I'm probably explaining this a little bit backwards, we'll have 0 inverted equals 1. And I forgot to actually mention this before, sorry. We're going to use a subtraction tool. So we double click in, and if the cloud would like to catch up, there we go. If we do a subtraction and take the value list, take the image sampler and subtract it from the value list. Essentially what this is doing is when it's normal, when this is going to stay normal, it's going to be whatever numbers come out of here, and if we invert it, then we get a, actually I think this might be backwards. Or it doesn't matter. Oh, sorry. It doesn't matter. Sorry. So when it's normal, it'll be the same values that are coming out of here, and when it's inverted, it flips. That's just in case the curtain wall panels are doing the opposite of what we want based on the gradient pattern. And the reason why I said it doesn't matter is because if we use an absolute value after this, plug that in, then those, even if we do go normal, it won't negate it. It's going to give it the absolute value of this result. Even if it's negative, it's going to turn it positive. Sorry about that. I hope that's not as convoluted as I think I just said it. Anyway, so now that we have an absolute value from all of the image sampler, what we want to do is plug it into an element parameter set. So what this is going to do is it's going to take the results that we're getting out of here, which is values between 0 and 1. We're going to plug that into the parameter value. And we're going to set this parameter key, which is the name of the parameter of the curtain panel, as offset factor. So if we can either type in panel, or I learned this shortcut, if you do 2 backslashes and then type in offset factor or whatever you want to input into the panel, if you hit enter, it automatically does it. It's kind of like just typing numbers into and creating a number slider. And then we need an actual element. So what we can do, we can either just plug a curtain panel in here and have it always update, or we can use what's called a stream filter. So the stream filter, what it does, if we use a button, so this gate is asking for either a value between 0 and 1, which it can be used as a true-false. Really quickly, so it takes whatever information is being streamed into each different input, and depending on the value of the gate, it outputs that specific stream. So, for example, I'll just do a quick 1 and 2 to 0 and 1. This is just an example. You don't have to copy me, but if we do an output right now, so the gate currently is on a false, and so or a 0, and so it's streaming this stream 0, which is 1. If we press the button, it switches to 2. Now, if we had a number slider in here from 0 to 3, let's say, what you can do is you can actually plug in more elements into the stream filter. And then depending on the number, it outputs that specific stream. Okay, so what we can do with this is basically leave the first stream or the false statement or the false stream as blank, and then plug in the element type, which if we go all the way back to the beginning of the script is back here. No, the other one here. There we go. We want the elements of there. And then we want to plug those elements into that stream filter into the element, and then when we hit true, it's going to run. And then if we drop down, ew, that's not right. Figured it out because I didn't have my Y value in for my remap numbers. Okay, I realized why it was screwing up. Not only did I have the X component in my Y remap values, but I also was using the wrong domain in my image sampler. So if you double click this, I hit this, which is getting the pixel ratio of the image, which is 1 to 1920. Don't want that because we're remapping the numbers between 0 and 1 for a reason. We're remapping all that XY coordinates so that they map on the image from 0 to 1 and 0 to 1 in the Y, 0 to 1 in the X. So if we hit OK, then all those get remapped correctly. So it was that's why the values were all jumping all over the place. And now it works perfectly. The one thing, I'm going to switch this back to a button so that it stops live updating. So if we look at this, so this is what I was talking about with the values being inverted versus normal. I want the panels to be open on the top right corner and closed on the bottom right corner. So what I need to do, go back into Grasshopper and go back to that component that we created. Component we created back here. Just kidding. Where are you? There we go. Our value list, and switch this from normal to invert. And then up at our gate filter, hit the button again to redo all those values. And now it's a gradient on the correct side. And if we go in and hide all of this geometry behind it, now we can see that we get a nice gradient panel, and all of these are individual curtain wall panels. Alright, so for your deliverables, I want a elevation of your gradient. And actually, now that we set this up, what I'd like you to do is choose a different gradient. So not this, not the angled one. Find a different gradient. You could find a image of a person, a cool pattern, etc. And maybe increase the amount of panels to get a higher resolution pattern. And then using that pattern, update your curtain wall panel, submit a PDF of an elevation that shows that pattern, as well as a 3D axon and a 3D perspective. Okay, and that'll be your submission. I'll write all this up on the assignment submission on Canvas. And good luck. Let me know if you have any questions.